Hello there. We'll be looking at a very special problem, Invoicer 3, which is, I believe, one of the least solved problems in the whole competition. And it's one I solved pretty early on, like 6 days ago. So, I'm wondering why that's the case. Well, we'll walk through the problem and see what could have went wrong with the others. What do you think? So, the description says secret data. And when we talk secret data, we of course think of a database, possibly an SQL injection. I'm just saying what I think out loud. We never know. So I'm currently logged in, right? And I'm gonna create some data because right now we have nothing. So we can't really see like if our injection, if our injection works, right? So blah 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 blah. So okay, we have data now. So if we try to query like Jim, we can get like the email. If we try to query the details, we get that as well. Try to query recipient, the amount as well, not the amount. So like all the fields here, you can like type a portion of it and it's gonna match, right? So in SQL, usually that's using a like command, a like syntax. So that's interesting. So we can try to imagine like what does the query look like. So it's probably like if we open this here, select like star from like users where x equals to like our input or y like input. So, and of course, or z, so that would be our like details, our email, or recipient email. So we can imagine that it may be wrong, but it will serve as a starting point for like the model of how the application works, right? So if like our input is duplicated, we need to take that into consideration, right? It might break stuff if we have like the same request multiple times. So let's try to do some testing, right? So of course, if we put like random, like xxx or just x, we get no result because none of our invoices contain the letter x. Let's try to put a quote like this, because can either be like a double quote or a single quote. Let's start with like a single quote and see what happens. So an error. That's a good clue, right? Because if it was just like passed into the like and not interpreted by the SQL interpreter, then there wouldn't be any issue. It would just return no result because no result contains a quote, right? It means it's being interpreted, but the SQL request is not valid because there's like a random quote that is never closed, right? So it's probably more like this then. Instead of like the double quotes, it's the single quotes. So if there's 3 quotes in a row, it's not valid. So okay, then if we have an x or 1 equals 1, we get nothing, which is interesting, right? I mean, 1 should always equal 1, right? So let's try to understand why. So it would mean like, let's remove this for now, like it doesn't really matter. Like, so we close the quote or 1 equals 1, right? So it should look something like this. I mean, one thing that's interesting to note is, well, first, it's not crashing anymore. So it means the request is valid, but the or 1 equals 1 is not working for some reason. And if we have the x here, we have everything we need. Weird, right? Maybe we can build on top of that. Let's see how, like, I don't remember how I solved it, like the initial request. I'm trying to find something that matches everything. So x, so I want this to be ignored basically, and be able to control like if there's values or not. And if we manage to do that, we can apply the same technique that you saw in SQL injection 3, where you know if you have some results, then this is true. If it's not, there's no result, then it's false. So let's see in the list of, so I have a bunch of stuff there, right? That's not working. Is it like, that's so weird. It's not liking it, right? I wonder why. So I'm just looking at the past request I did, so it's up to 4,000. I think a few people tested on it. So if we do this, it does match this, so I'm just not sure why. Why empty is not equal to empty. I guess maybe. Okay, now we control it. What's the difference? It's the equal, right? That's weird, right? So possibly I'm not quite sure, but it's not equal to 1. But you can see that we can control depending on if this is true. So let's say like we know this is false, right? So x is not equal to 1. So let's put another expression, another statement to the expression. 1 equals 1, or so here we can control it, right? So we have a template for execution, right? We have this. So we can put any expression there and know if it's true. If it's true, there will be all the queries returned. If it's false, there's going to be nothing, right? That depends on the fact there's no x anywhere. So what can we look at? Well, one interesting thing we can look at is the list of tables, and let me show you how we do it. So one first thing I wanted to check is like, how do I find like any entry that starts with like a certain character? So the way I figured out to do it is with a subquery like this, and you can do select the count from users where first name, actually it's not users, it's invoices. Like here I guessed a little bit and eventually I got it, but it was just to find out like if I could do it like something. So not right now it's just returning. So let me show you what I'm doing. Right now I'm doing selecting the count of invoices that is greater, like if the count is greater than 0, this is gonna return true. So we can actually like figure out the number of invoices by like binary searching like this. So we can look like, okay, is it greater than 1000? Like yes. So we can guess by the ID that it's like 4000. Let's say we do this, then we can actually like binary search for the number. But that's not really what we care about, right? We don't know yet what we care about, but we know we can like guess some information like that. So what else can we do? We have some fields here. Like let's just look at the network to see like the structure a little bit. So application and yeah, the response. So invoices, response is the pure HTML, so we're not gonna have like the raw structure, but we can guess like, let's turn that back down, where details let's put it like this. So that's the number. So we know details is a valid column, otherwise it would have crashed, right? So you can check the number of invoices that the details start with sad, but if we put like another thing like that, it's gonna fail or not. So let's just put a bunch, because maybe there's like, okay, so now it's returning nothing, because maybe there was like input from like other users, because we have access to all the invoices, not just the ones that have our ID right now. So I don't really care about the invoices, at least I don't think so. What I care about is listing the tables. So there's a nice site I found named SQLinjection.net, and it's basically a guide to like how to do certain SQL injections. So there's by union. Right now we don't have control but with our union because it's breaking, right? But it gives us the where we can find the table names. So we can try in MySQL, SQL Server, and Oracle, but I can show you, I tried all of them and none of them work, and I was so stumped as why is it not working? Like I tested the count star method was working, but I couldn't make that work. Like let me show you. So let's just select table name from yeah, I need that. So basically that's gonna count the number of tables, right? But it's not gonna work. I'll tell you why. So it's crashing. So the reason it's not working is because it's not a MySQL database, it's not a SQL Server database, it's not an Oracle database, and like I really didn't know what else it could be. Like hopefully it wasn't like some esoteric database. But I remembered like one that is pretty popular in CTF is not SQLite, is what is it again? SQLite. So I searched for SQLite list tables, and this is what was like my last hope for finding how to list the tables. So there's this, but this isn't very useful in a select statement. And I kept looking. So I found this, select name from SQL master. And then I was like, oh, this looks promising. So let's look at this SQLite master. Type equal table. Yeah, this look good. These look good. And look at this. It returns stuff. That means that this subquery returns more than one element. It means it's returning the tables. So how do we leak the table names from this? Well, we use the same technique that we learned from the other challenge. We do like this, where table name like something, and then we start by like using A, B, C, D, E, F, G, H, I, all the letters, all the printable characters, and there's some that are hard to handle, like underscore, because that's a character that can be used in like to say like any character. So you can write a script to do that, but let me just show you an example first. So what did I? Yeah, I used double quotes, so I'm probably gonna use quotes to stay. What's the issue? I probably is it not table name? It's just name. So it's working, no error. And we can even do like invoices. So I know this table exists, so it's returning something, but let's say like you invoice X, then it's gonna return nothing, because this query returns nothing. So you have to basically enumerate every possible letter. Then each time it returns something, it means it's a possible prefix, so you keep iterating for every other possible letter in front of it. So I'm not gonna write the script in front of you. I think I have it somewhere in my, hopefully I didn't delete it. So I have so much crap lying around. So I have like blind. That's the other challenge. I have, let's, fuck this, that PI, no, it's not that one. It's not intros. Maybe it's, no, it's not that one, that's crypto. Is it? Maybe not. That's a time-based. So I guess I don't have it anymore. Crack? No. Captcha? No. Blind? I don't have it anymore. So I can try to enumerate the table names, and then basically you do the same thing, but for the columns of that table name, and then you do the same thing for the value of the column. So you have to do like 3 separate like enumeration using the same technique. You just modify the query a little bit to like select the column name where table name equals the one you found. And okay, so I'm just gonna show you how to like leak the table names, and I think that's gonna be good enough. So inv3.py import request. So to be able to do, let's do like a dummy request and see if it works. Like nothing like that, and we want to return those two. We need to add the cookie from the request, right? So we have this cookie here. We can copy copy the value like this, I guess. So cookie Invoicer session. I don't really care right now. Okay, so this is the cookie. Yeah, session. Okay. And when we the URL is this, so we get the URL, and I think we need to put the, maybe not, let's just leave it like this. I think I'm gonna debug it if there's a problem. So everything's fine. We have my email here, we have my other email, so it's successfully gathering this stuff. So we just need to replace what's in the keyword here, right? So we can write a function that takes in a prefix, URL, target URL. We need to generate the URL we're gonna use, since like, and then we add the payload, right? So the payload is keyword equals to whatever we're trying, right? And I think we need to URL encode our prefix. So relib that parse the encode prefix. I think let's just look a little bit. So code query string. So it's a lot of googling, a lot of mess testing until like stuff works. So once you know the technique, I think like it's not straightforward, but at least like it just takes the time, you know. You need to put in the time, and then it's fine. I'm probably gonna like remove the keyword here. So keyword and then prefix, right? So you can like print the target URL, check for like, so now we're leaking table names, right? So actually we're just gonna put like A, it's fine. Keyword equals A. Yeah, that looks legit. So now we need to actually do the query. So target URL like that. So in response to that text request. Okay, so I have my email and everything, so everything's good. And the URL, I didn't print it anymore, but it contains our stuff. Didn't test with let's test with that one. So that should return everything as well. This, so put in like this. So yeah, it returns everything. So this is working as well. It's encoding all the commas correctly. We're in business. So now we want to check if it returns anything or it returns nothing, right? So if we query like potato, then it prints you have no invoice yet. So we can use that. So we can return in response that text. So it's gonna tell you if there's something that's returned. So if the expression is true, right? Now we could like wrap that. To make it a little bit cleaner. So remove this and put like the expression. Like that. Now we don't need to worry about like actually we just need to like put the internal query, right? So we care about that one currently. So now we're getting deeper and deeper. So is table prefix. So we can do a few tests, right? So I should return syntax error because I forgot this. True. True. What about P? Then false. Okay. What about invoices? True. True. False. Okay, so we have our function. So now we just need to enumerate everything. So we can do that with breadth first search basically. So if from collections import DQ, we just like implement the regular breadth first search algorithm, because basically the characters are like a tree, right? Like at the root you have like the empty string, then each valid prefix is gonna be like a branch going down. So we also need our car set. We can like start with like BDC, like I'm gonna like import string, and then you can do like string that ASCII lowercase plus string that ASCII uppercase plus like string that digits plus like underscore, but you need to like escape it maybe, and like this. I don't know what else I could check for. So yeah, while q cur equal q.pop left, so that's the prefix, current prefix. C and car set, so we want to is table prefix cur prefix plus C. If it's true, then you append cur prefix plus C. And if you didn't find any found equals false, so yeah, if you don't find any like character that comes after the current answer, it means like you already found the answer, right? So we can try this. Like this. It's not working. What's missing? What's missing? No, yes, because I'm not printing the correct thing. So now it's trying all the letters, and I should print when it's so A, found I, found U, found A, I. So now it's gonna try all the next characters for every successful match. So it's gonna take a while. And there's probably some mistakes, like I didn't escape the underscore, so underscore is gonna match everything every time. So you can escape it like this. Oh yeah, we have to escape the backslash too. So let's give it a while. Okay, good. So AR in so how was your day? Yeah, there's probably some more efficient way to do it, so I was thinking using some async stuff to make multiple cores at once, but I just like went and did something else because sometimes you need a break. So I saw this as an opportunity to take a break instead of like trying to optimize it, you know. So AR seems promising, maybe. I didn't need to put AC ASCII uppercase. I think it's worth removing it because it's doubling the time number of checks. I think don't need the digits as well. Let's just leave it like this and hopefully it's gonna be good enough. Like this is some things you need to try out, right? So if I recall correctly, there's no like uppercase. Well, like the like doesn't consider uppercase, so you don't need to even check it. But like for numbers, I don't think the table contains the numbers. So we have yes up, okay. And this one is gonna be invoices. Oh, what happened? Oh. Index, envoy. It's gonna be invoices. And this is probably gonna be schema something. So this is when you're happy about having a good internet connection. Because if your connection is bad, you can be sad in this situation because like blind injections are always like slow. At least, well, even if it would have been time-based, I wouldn't have been that worse. But so we have a list of matches, but this is one bug in my solution that I wasn't able to find because basically invoices is fine, SQLite, schema and everything. It's the super that's the AR. I think that's missing, either missing characters. I know the super is the underscore that's not being considered correctly because if you do super like this, it's gonna be fine. And I can speed it up. I think it's like super hidden secret flag, right? So the table name is super hidden secret flag. So then you want to find the columns from this table. So you need to copy this instead of select from super hidden secret flag, where like, no, actually you need to select from SQLite master. I don't remember the column name. I think I guessed like flag, but it didn't work. Yeah, because it doesn't, it's not a valid query, so it's gonna think they're all correct. So we have to look at this again. SQLite list columns for table. Yeah, I see the purple link right here. Let's look at it. Select SQL. Yeah, you have to leave the SQL schema and then you can leak the value from the table using the column you found. And I'm not gonna do it because it's basically the same thing as this. You just change the query to like leaks is schema prefix, and then you like do this, then is flag prefix. So the flag is inside the super hidden secret flag, and I don't remember the column, but doing the same technique you can leak it. So I'm gonna leave the rest as an exercise to the viewer. Hopefully you learned something. I know I had a lot of fun doing that one. And yeah, see you next time. Bye.